Hey there, welcome back to a video that might just make you think twice about that classic car sitting in your neighbor's driveway. We're diving into one of automotive history's darkest chapters, cars that exploded without warning because someone somewhere thought their fuel systems were good enough. If you love car content that goes beyond the surface, make sure to hit that subscribe button right now. Trust me, you won't want to miss what's coming. Let's get into it. The Ford Pinto is the poster child for automotive disasters. Between 1971 and 1980, Ford sold millions of these compact cars with a fuel tank positioned directly behind the rear axle. Rear-end collisions, even at low speeds, would rupture the tank and spray fuel everywhere. The filler neck would separate and sparks from metal grinding against metal would ignite the gasoline. What makes this truly insane? Ford knew about it. Internal documents showed they calculated that paying off lawsuits would be cheaper than redesigning the fuel system. They literally did the math on human lives versus dollars. The tank could have been moved for about $11 per car, but they chose profits over safety. Dozens of people burned to death in Pintos, and it became the textbook example of corporate negligence in every business ethics class. Then there's the Chevrolet Corvair, which Ralph Nader made famous in his book Unsafe at Any Speed. While Nader focused on the handling, the fuel system was equally terrifying. The Corvair's engine was in the rear, and so were its fuel lines running through the passenger compartment. Any accident that damaged these lines meant gasoline pouring directly into where people were sitting. Early models had no protection for these fuel lines whatsoever. A minor fender bender could slice through them like butter. Chevrolet engineers raised concerns during development, but management pushed forward anyway. The car looked revolutionary and they wanted it on the market fast. That rush to market cost lives when accidents turned into infernos that passengers couldn't escape from. The Pontiac Fiero seemed like such a cool idea. A mid-engine sports car from an American manufacturer in the 1980s positioned to compete with European roadsters. Problem was, the first model year 1984 had a devastating flaw. The engine would overheat, and when it did, poorly routed fuel lines would fail. Gasoline would leak onto the scorching hot engine components and ignite. Hundreds of Fieros burst into flames while just sitting in parking lots or cruising down highways. Owners reported seeing smoke, then flames with almost no warning. Pontiac issued recalls, but the damage to the car's reputation was permanent. The really maddening part, the overheating issue was documented during testing, but release deadlines took priority. They figured they'd fix it later. Later came too late for people watching their dream cars burn. The DeLorean DMC-12 is remembered for Back to the Future, but it had serious fuel system problems that could have made it famous for all the wrong reasons. The stainless steel body gets all the attention, but underneath, the fuel injection system was a nightmare. It used a Bosch K-Jetronic system that was prone to leaking at multiple connection points. The fuel accumulator, mounted in the engine bay, would crack under heat stress. When it leaked, fuel would drip onto electrical components. Several DeLoreans caught fire, and owners reported the smell of gasoline inside the cabin while driving. John DeLorean's company was so focused on the car's appearance and movie-ready looks that quality control on critical safety systems took a backseat. They were building a brand, not just a car, and cutting corners to make it happen. Ferraris from the 1970s and 80s, particularly the Testarossa and the 308, had fuel system fires that became an open secret among collectors. The fuel lines in these models degraded over time, especially in cars that sat unused. When owners fired them up after storage, brittle fuel lines would crack and spray pressurized gasoline all over the engine bay. These are engines that run incredibly hot. It's the perfect recipe for disaster. Ferrari's response was essentially that these were high-performance machines requiring meticulous maintenance. But here's the thing, the fuel line materials they chose weren't suitable for the heat these engines generated. It wasn't owner neglect, it was a design flaw. Mechanics who specialized in Ferraris knew to replace every fuel line as preventive maintenance, which tells you everything about how inadequate the original components were. The Audi 5000 from the mid-80s is famous for unintended acceleration, but fewer people know about its fuel system vulnerabilities. The fuel pump and lines ran through areas that would crumple in side-impact collisions. When hit from the side, the fuel system would rupture and ignite, turning survivable crashes into fatal fires. German engineering was supposed to be the gold standard, but Audi had prioritized performance and luxury over crash safety and fuel system placement. After multiple deaths, investigations revealed that the fuel tank and pump assembly had minimal protection in side impacts. Audi eventually redesigned it, but for years they sold a car where getting T-boned at an intersection could mean burning alive even if the impact itself was survivable. The Yugo, that infamous symbol of cheap automotive failure, also makes this list. Imported from Yugoslavia in the 1980s, it was marketed as the most affordable new car in America. You got what you paid for. The fuel system used the lowest grade components available with rubber fuel lines that deteriorated rapidly. Clamps would loosen, connections would fail, and gasoline would leak all over the hot engine. There are documented cases of Yugos catching fire in driveways, at gas stations, and on the road. The quality control was virtually non-existent. Each car was essentially a lottery ticket, and if you got unlucky with your fuel system assembly, you might end up with a rolling fire hazard. American regulators eventually tightened import standards partly because of how bad the Yugo was. The Mitsubishi Pajero, sold in some markets as the Montero, had a fuel tank placement issue that led to explosions and rollover accidents. The tank was mounted on the side of the vehicle, and in rollovers it would be crushed and ruptured. Fuel would pour out and ignite from sparks or hot components. What made this especially bad was that the Pajero was marketed as an off-road adventure vehicle. People bought it specifically to take on rough terrain where rollovers are more likely. Mitsubishi knew the vehicle had a higher rollover risk due to its high center of gravity, yet they placed the fuel tank in the most vulnerable position possible. After deaths in several countries, they were forced to redesign the tank location, but not before years of avoidable tragedy. The Volkswagen Type 2, the classic hippie van everyone loves, had a fuel system that was a ticking time bomb in frontal collisions. The engine was in the rear, but the fuel tank was up front, right behind the thin front panel. There was essentially no crumple zone. Hit something head-on and the fuel tank would rupture immediately, spilling gasoline into the front of the vehicle where it would ignite. Passengers had almost no chance if fire broke out because the doors could jam in frontal impacts. VW sold these vans for decades with this design, making only minor improvements. The thing is, people didn't buy them for safety. They bought them for style and utility. VW knew this and didn't prioritize redesigning the fuel system until regulations finally forced their hand. The Chevrolet CK pickup trucks from the 1970s and 80s had fuel tanks mounted outside the frame rails, a design choice that sounds insane now. Inside impact collisions, these side-mounted tanks would be punctured and explode. We're talking about trucks that were everywhere, used by families, contractors, and businesses. General Motors sold millions with this side-saddle fuel tank design. When the deaths started piling up, GM fought lawsuits for years, arguing the design met standards at the time. Technically true, but standards were inadequate and GM knew it. Internal documents showed engineers had recommended moving the tanks inside the frame rails, but it would have cost more and reduced fuel capacity. So they left them outside, exposed, where a side collision could turn the truck into a fireball. The Trabant, that iconic East German car made partially from recycled materials, had a two-stroke engine that leaked oil and fuel constantly. The fuel system was primitive even by 1960s standards when it was designed. Fuel lines were basic rubber tubing, the carburetor was crude and everything leaked. Trabants were known to catch fire randomly, sometimes while parked. The fuel system had no modern safety features whatsoever. But here's the context. It was built in a communist economy with limited resources and no competition. Safety wasn't even a consideration. It was about producing a car, any car, that citizens could theoretically buy. The result was a vehicle that was more fire hazard than transportation, but millions of people drove them because there was no alternative. The Dodge Dart and Plymouth Valiant from the 1970s had fuel systems that corroded from the inside out. The steel fuel tanks would rust, especially in areas with salted winter roads, and develop leaks. Owners would suddenly smell gasoline, look underneath, and see fuel dripping from pinholes in the tank. If that fuel hit any hot component or spark, it would ignite. Chrysler used cheap steel to save costs, and they didn't adequately protect it from corrosion. These were popular cars, considered reliable for their time, but the fuel system was a disaster waiting to happen as the vehicles aged. The really frustrating part was that rust-proofing technology existed, but applying it to fuel tanks would have added to manufacturing costs. The Ford Mustang II from the mid-70s shares some of the Pinto's problems because it was built on the same platform. Same poorly positioned fuel tank, same risk of rupture and rear impacts, same corporate decision-making that prioritized cost over safety. Ford essentially took the lessons they should have learned from the Pinto disaster and applied them to another model. The Mustang II sold well because it carried the Mustang name and appealed to buyers during the fuel crisis. But it carried the same deadly flaw. Rear-end collisions could rupture the tank, spray fuel, and ignite. Ford eventually made changes, but only after the Pinto scandal forced their hand. How many people at Ford had to approve putting the same dangerous fuel system in another car? The Renault Dauphine, sold in America in the late 50s and early 60s, had a rear-mounted fuel tank with lines running through the interior. Any collision that compromised the fuel system meant gasoline pouring into the passenger compartment. The car's body was also incredibly flimsy, so even minor accidents could rupture fuel lines. French engineering at the time prioritized compact design and fuel efficiency. Safety was barely a thought. American buyers found the Dauphine charming and economical, but accidents revealed just how dangerous it was. Reports of fires after collisions led to safety investigations, and the Dauphine became one of the early examples that spurred the creation of automotive safety standards in the United States. The Hyundai Pony, sold in the late 70s and 80s in various markets, used fuel system components that failed prematurely. Fuel pumps would malfunction and leak, fuel lines would crack, and the carburetor would flood. Several ponies caught fire due to these failures. Hyundai was new to exporting cars and was competing on price. That meant using the cheapest possible components and minimal testing. The Pony was how Hyundai entered global markets, and quality control was sacrificed for affordability. Owners in Canada and Europe reported fires, fuel leaks, and the smell of gasoline while driving. Hyundai gradually improved quality, but the early ponies were dangerous examples of what happens when a manufacturer cuts every possible corner to hit a price point. The Alfa Romeo Alphasud from the 70s had fuel system corrosion issues similar to some American cars, but worse. The steel used in the fuel tank and lines was incredibly prone to rust. These cars would be only a few years old and already have rusted through fuel tanks. Owners would park them and return to puddles of gasoline. If the car was running when a leak developed, fire was a real risk. Alfa Romeo's quality control during this era was notoriously bad. They were building beautiful cars with serious structural and safety issues. The Alphasud is remembered fondly for its handling, but anyone who owned one knew you were constantly battling corrosion, and nowhere was that more dangerous than in the fuel system. The Subaru Samber, a small commercial van sold mainly in Japan and some export markets, had fuel system fires linked to deteriorating fuel lines and poor electrical grounding. Fuel would leak onto electrical shorts and ignite. These were work vehicles, often loaded with cargo and used hard. The combination of vibration, heat, and constant use meant fuel system components wore out fast. Subaru issued service bulletins, but many Sambers were owned by small businesses that deferred maintenance. The result was a rash of fires that damaged cargo and put drivers at risk. The Samber was designed to be cheap and utilitarian, and the fuel system reflected that bare-bones approach. The Lancia Beta from the 70s is another Italian car that rusted aggressively, and the fuel system suffered badly. Fuel tanks would corrode and leak, fuel lines would rust through, and the car would drip gasoline. Several Betas caught fire due to these leaks. Lancia's reputation took a massive hit in markets like the UK, where road salt made the corrosion even worse. The company eventually bought back and crushed thousands of Betas in Britain to end the scandal. It's one of the most dramatic automotive recalls in history, driven largely by fuel system failures. Lancia used poor quality steel and inadequate rust protection, knowing these cars would be sold in harsh climates. The FSO Polonaise, built in Poland and exported to various markets, had fuel system build quality that was shockingly bad. Fuel lines were poorly secured, connections leaked, and the fuel tank had inadequate baffling, which caused sloshing and stress on seams. The result was frequent fuel leaks, and several fires were reported. Like the Trabant, the Polonaise was a product of communist-era manufacturing, where safety and quality were secondary to meeting production quotas. It was sold cheaply in Western markets as a budget option, and buyers got what they paid for, a car with a fuel system that could fail in multiple ways, often simultaneously. The Datsun F10, sold in the late 70s, had carburetor flooding issues that would spill gasoline onto the hot engine. Several F10s caught fire while idling or shortly after being parked. The carburetor design was flawed and the overflow didn't adequately route fuel away from ignition sources. Datsun, which later became Nissan, was aggressively expanding in Western markets and pushing out models quickly. Quality control suffered. The F10 was supposed to compete with European hatchbacks, but reliability problems, including the fuel system fires, hurt its reputation. Datsun issued fixes, but the damage was done. The Chevrolet Vega, built from 1970 to 1977, had fuel line routing that brought lines close to hot exhaust components. Over time, heat would degrade the lines, causing leaks that would drip onto the exhaust and ignite. The Vega also had engine problems that caused overheating, which made the fuel system failures worse. Chevrolet was trying to build a competitor to small imports, but they rushed it. The result was a car plagued by problems, including a fuel system that could turn dangerous as the car aged. The Vega became synonymous with American automotive decline in the 70s. The Mazda RX-7, particularly early models, had fuel injection systems that could leak at the injector seals. When they leaked, fuel would spray onto the hot rotary engine and ignite. Rotary engines run hotter than piston engines, making any fuel leak especially dangerous. Mazda eventually improved the seals and fuel line routing, but early RX-7s had a reputation among mechanics for fuel system fires. Owners loved the car for its performance, but you had to be vigilant about maintenance. The rotary engine was innovative but also created unique challenges that Mazda didn't fully anticipate when they designed the fuel system. The Hillman Imp, a British car from the 60s, had a rear-mounted engine and a fuel system that ran through the passenger compartment. Sound familiar? It's a recurring theme. The Imp also had a pneumatic throttle system that could leak and fuel lines that degraded quickly. Several Imps caught fire and the car's reputation suffered. British Leyland-era cars had notorious quality control problems, and the Imp was no exception. It was supposed to compete with the Mini, but reliability issues, including dangerous fuel system failures, kept it from ever achieving that success. The AMC Gremlin, another American subcompact from the 70s, had a fuel tank positioned above the rear axle, vulnerable in rear collisions. Like the Pinto, impacts could rupture the tank and cause fires. AMC was a smaller manufacturer struggling to compete, and they cut costs wherever possible. The Gremlin was quirky and sold reasonably well, but its fuel system design was a liability. Several lawsuits alleged that rear-end collisions caused fatal fires due to the fuel tank placement. AMC made some modifications in later years, but the early Gremlins shared the same deadly flaw as many of their competitors. The Reliant Robin, that famous three-wheeled British car, had a plastic body and a fuel system with minimal safety features. The fuel tank was mounted in a position that made it vulnerable in the rollovers that Robins were unfortunately prone to. When they tipped over, which happened more often than any car should, the fuel system could rupture and leak. There are documented cases of Robins catching fire after rollovers. The whole design was unconventional, and safety was clearly not the priority. It was about creating the cheapest possible vehicle that qualified for certain tax and licensing advantages in the UK. The fuel system reflected that budget-first approach. So why did anyone approve these fuel systems? The answer is depressingly simple: cost, speed to market, and the lack of regulations. In the 60s and 70s, automotive safety standards were minimal compared to today. Manufacturers knew they could get away with dangerous designs because the lawsuits and bad publicity were cheaper than engineering better solutions. Engineers raised concerns, but executives made the final calls, and those calls were driven by profit margins and production schedules. It took disasters, deaths, lawsuits, and public outrage to force change. Organizations like the National Highway Traffic Safety Administration in the US were created partly in response to these failures. Regulations were written in blood, as the saying goes. Every safety standard we take for granted today exists because cars like these exploded, burned, and killed people. The engineers who approved these fuel systems weren't incompetent. They knew the risks. But in corporate cultures where quarterly earnings mattered more than human lives, those risks were deemed acceptable. That's the truly horrifying part. These weren't accidents of ignorance. They were calculated decisions, and that's why this chapter of automotive history should never be forgotten. It's a reminder that safety doesn't happen automatically. It has to be demanded, regulated, and enforced. Thanks for watching. If you found this eye-opening, hit that like button and subscribe for more deep dives into automotive history. See you in the next one. Before we wrap up, I want to emphasize something really important. These weren't isolated incidents or freak accidents. This was a systemic problem across the entire automotive industry, affecting manufacturers from every continent and every price point, from luxury brands to budget vehicles. From American companies to European and Japanese manufacturers, the pattern was the same. Someone in a boardroom decided that safety improvements could wait, that regulations were suggestions, that lawsuits were just part of doing business. And people died because of those decisions. The families who lost loved ones in these vehicles didn't just lose a person. They lost their future, their stability, their peace of mind. A child burned to death in a Pinto crash that could have been prevented for $11. A family incinerated in a side impact collision that better fuel system placement could have survived. These weren't statistics. They were human beings, and they deserved better. What's remarkable is that despite all these failures, the automotive industry learned almost nothing voluntarily. Change only came when regulators stepped in, when lawsuits became too expensive to ignore, when public outcry made ignoring the problems impossible. Even then, manufacturers fought every step of the way. They hired lawyers instead of engineers, lobbyists instead of designers. They delayed recalls, buried reports, and argued that their design met the technical standards of the time. But meeting a standard isn't the same as being safe. A standard is just the minimum someone decided was acceptable, and for decades the minimum was dangerously low. Today's vehicles have fuel systems that are dramatically safer. Fuel tanks are reinforced, protected by crumple zones, and positioned to minimize rupture risk. Fuel lines are routed away from hot components, made from materials that won't degrade, and equipped with shut-off valves that activate in crashes. Modern cars have multiple redundancies because engineers learn the hard way what happens when you don't. A fuel system today has to survive impacts, fires, vibrations, temperature extremes, and corrosion. But that wasn't always the case. Every safety feature you're protected by exists because someone fought for it, usually after people died. That's a sobering thought. It should make you appreciate modern safety standards. It should also make you skeptical of anyone who wants to roll back regulations in the name of profit. Because we know where that leads. We've seen the bodies, we've read the lawsuits, we know the cost of cutting corners. As you go forward, remember this when you hear arguments about regulations stifling innovation or cutting into profits. Innovation in safety is still innovation. Protecting human life is still a business priority, or at least it should be. The companies that understood this decades ago are still around. The ones that didn't, well, some of them folded entirely. Their legendary failures became textbook cases in business schools. The Ford Pinto became the example of how not to run a corporation. The Yugo became a punchline, but the real tragedy isn't the corporate failures, it's the lives lost along the way. If you're driving an older vehicle from this era, especially one of the models we discussed, please have it inspected by a qualified mechanic. These cars are now vintage or classic, and they're being restored and driven by enthusiasts. But restoration requires more than just making them look good. The fuel system needs to be thoroughly examined, repaired, or replaced with modern components if necessary. An original fuel system in a 50-year-old car is a disaster waiting to happen. And if you love classic cars, you can still enjoy them safely. You just have to be intentional about it. Check your fuel system regularly, understand the risks, and don't ignore warning signs like gasoline smells or visible leaks. Your life is worth more than keeping a car original. This whole journey through automotive history shows us that progress isn't automatic. Safety improvements didn't happen because manufacturers suddenly developed a conscience. They happened because people demanded them, because activists like Ralph Nader exposed the dangers, because regulators created standards, and because courts held companies accountable. Every airbag, every crumple zone, every fuel shutoff valve, every seat belt pretensioner exists because someone fought for it. And we should never take that for granted. We should never assume that profit-driven corporations will always put safety first. We should remain vigilant, keep questioning, and keep demanding better. Because the alternative is a world where cars explode without warning, where people burn alive in survivable crashes, where corporate negligence is just another cost of doing business. Thank you so much for sticking with me through this heavy but important topic. If this video has taught you anything, please share it with others. Help spread awareness about automotive history and why safety matters. Subscribe to the channel if you haven't already, because we explore topics like this constantly. We dig into the stories that shaped industries, that changed lives, and that remind us why accountability is essential. Hit that like button if this resonated with you, and let me know in the comments which of these vehicles surprised you most, or if you have personal stories about older cars with fuel system issues. I read every single comment, and I'd love to hear from you. Thanks again for watching, and I'll see you in the next video.